Welcome to Learn Chemistry Together. This video is about problems. Polar covalent bond. Consider the structure of methanol. Identify all polar covalent bonds and show any partial charges that result from inductive effects using the following 3 steps. Step 1. Identify all polar covalent bonds. First, identify all polar covalent bonds. The CH bonds are considered to be covalent because the electronegativity values for C and H are fairly close. It is true that carbon is more electronegative than hydrogen, and therefore there's a small inductive effect for each CH bond. However, we will generally consider this effect to be negligible for CH bonds. The CO bond and the OH bond are both polar covalent bonds. Step 2. Determine the direction of each dipole. Now determine the direction of the inductive effects. Oxygen is more electronegative than C or H, so the inductive effects are shown by 2 blue arrows. Step 3. Indicate the location of partial charges. These inductive effects dictate the locations of the partial charges. Next, let's practice a few problems. In structure A, oxygen is more electronegative than carbon, and a CO bond is polar covalent. For each CO bond, the O will be electron-rich delta minus, and the C will be electron-poor delta plus, as shown. In structure B, carbon is more electronegative than magnesium, so the C will be electron-rich delta minus in a CMG bond, and the Mg will be electron-poor delta plus. Also, bromine is more electronegative than magnesium, so in an MgBr bond, the Br will be electron-rich delta minus, and the Mg will be electron-poor delta plus. In structure C, oxygen is more electronegative than carbon or hydrogen, so all CO bonds and all OH bond are polar, covalent. For each CO bond and each OH bond, the O will be electron-rich delta minus, and the C or H will be electron-poor delta plus. Lastly, in structure D, oxygen is more electronegative than carbon. As such, the O will be electron-rich delta minus, and the C will be electron-poor delta plus, in AC equals O bond. Thank you for watching. Click subscribe for more.